In this example, we draw marbles from a box with replacement. I'm sorry, without replacement. So here we do not replace the marbles. A box contains 3 red tickets and 7 blue tickets. Well, I'm switching from tickets to marbles. Sorry, let me just write tickets. Either way, marbles or tickets. Okay. One ticket is drawn at random. The color is noted. The ticket is not replaced in the box. So you don't put the ticket back in the box. A second ticket is drawn. Its color is noted. A. What is the probability that the first ticket is red? So we have the box with 3 reds and 7 blues. The probability of red is 3 reds out of a total of 10, which is 30%. So what is this probability, or you could say what are the chances, that the first ticket is red and the second ticket is blue? So we're talking about probability red then blue. Well, what happens is you pick the first guy, and that we have 3 and 7, 3 red, 7 blue. So the probability of red is 3 out of 10. So 3 out of 10 times you're going to get a red marble in the long run. So if you did it over and over, your average of reds would be about 3 out of 10, 30%. But then what you do is you don't put that back in the box. If you got a red, you don't put that back, the red back. And now we're asking, what's the probability of blue, given that you got a red the first time around? Now, so what's happening is 3/10 of the time you're going to get a red, and then out of those 3/10, how many times will you get a blue? 7 out of, well, we're assuming that we don't have that red anymore. You only have 2 reds anymore, so it's going to be 7 out of 9. So it's what you do is multiply the probability the first thing happens, which is pulling a red out, that's 3/10, times the probability of the second thing that happens, which is getting a blue. But we write conditional probability because in this case, it's a conditional probability because the likelihood of getting a blue changes from the first box because we already took a red out. Now, there's some reducing of fractions, and we're going to get 7 over 30. What is the probability of drawing a blue and then another blue. So what we have is the same box as before. We're looking at probability blue, blue. So it's the probability the first one's blue, this probability that the second one's blue, given that the first one's blue. So if you look at this box, there's 7 out of 10 are blue, then we multiply, but now we have a new box where there's only 6 blues because we're not doing this with replacement. This is without replacement for this problem. So that's a big issue or a big thing to look at if you have replacement or not. If there's replacement, you're going to keep the same box, but here we're changing the box, and now we have 6 out of 9 are blue, and then that reduces to 7/10 times 2/3, so that makes 14 out of 30. D, what is the probability of drawing blue and then red? So we're looking at probability of blue, red. So that's going to be the probability of blue. That's the probability the first thing happens, blue, and then getting a red given that the first one's a blue. So you have this box, 3 reds, 7 blues. The probability of blues is 7 out of 10. But then we move on to a new box because again, this is without replacement. And we have 3 reds. We took a blue out, so now there's only 6 blues. So we multiply by, we're trying to get a red. We want to see what happens when we get a red. There's 3 out of 9 reds. So that's 7/10 times 1/3. So that's 7 over 30.